Okay, here go the notes. We are in logarithms. Here's the notes for the worksheet 5 logarithms. So worksheet number 5 on logarithms. Okay, so the good news is we're not really going to see anything new that we haven't seen, but now the problems are going to get more complicated. So here's what I'm talking about. Okay, what am I talking about? Well, remember these problems where it said something like evaluate and let's do one of them that you already know. Something like log 2 32. Now some of these easy ones, again, just don't do it in your head. Show the work, be sure of the answer, because now you're going to see some of the complicated ones, and don't assume it's one of the easy ones. So this is one of the easy ones. Let me tell you how you're supposed to do it. Don't try to guesstimate or predict the answer. What are we supposed to do here? Well, we're supposed to put log 32, and we're missing the equal sign and then the x, right? We've got to find this. And again, remember we changed to, remember to convert to exponential form, right? Convert to exponential form. We always work in exponential form. Exponential form. So we do this counterclockwise bit, and this is now going to read what? 2 to the power of x is equal to 32. Right? And now that we have it in exponential form, what do we try to do here? Well, we try to get the same what? The same base. Remember, this is where you're just working with bases and exponents. Bases and exponents. Okay? So this is the reason we don't work in logarithm form. We change it to exponential form, and then we work with bases and exponents. And then this is going to be 2 to the power of x is equal to, and can 32 be written with a power of 2? The answer is yes. It's 2 to the 5. Right, and once the bases are the same, once these bases are the same, then we're supposed to solve what's up here, but you know, there's nothing to solve. It says what? X is equal to 5. Right? Okay. Now, I'm not going to do one of the new ones yet, but I just want you to look at this one. This one says log 2 base 32, right? The new ones will say it like this, right? It can be an easy one, or it can be one of these new or more challenging ones. The new ones will look and say something like log 32, and then the 2 will be here. See, that's not the same problem. That is a different problem, and we are gonna do this. We are gonna do this, right? To solve it, we are gonna change it to exponential form. But see, it's a different ballgame. See, now it's not saying the same thing as this. Okay, so we'll get to these in a bit, okay? So my point is to you, whether you think it's an easy one or if it's a difficult one, you don't worry about that. You change it to exponential form, and then from there you'll know if it's one of these easy ones or the difficult ones. Okay, let's do one more. One more of these easy ones, number 2. Well, what about log 8 1/64? What about something like this? Okay, well, again, let's not try to think, let's not panic, let's just stick to the steps, stick to the way we're going to solve any and all of these, and you should be okay. So what's the deal here? Well, we got to put equals x, right? That's the part that's missing, because I have to change it to exponential form, right? It doesn't. It has to, usually it says equals a number or something, and if it doesn't, you have to add this part. Okay, so now we change it to exponential form, and then we do what? We do that business there, right? Counterclockwise, start with the bottom, counterclockwise. This now, in exponential form, is reading what? Well, now it's going to say 8 to the power of x equals 1 over 64, right? And let me move this up here. And now this is where, let me write it over here, 8 to the power of x is equal to 1 over 64. Here's where you just look at the big numbers. Don't worry about the 1. We're going to move this up. Here's where you look at this. This has a base of 8. Can 64 be written with a base of 8? Yes, of course. So that's going to be, remember, because once we have it in exponential form, right, this is exponential form. You don't see this. You don't see the logarithm anymore. Once you have it in exponential form, you're just working with bases, and exponents. I'm trying to get the same base, right? I'm trying to get the same base. So I'm using the base 8, and 64 can be written as what? 64 can be written as what? 8 squared. See, I'm getting the same base. And I got 8 to the power of x is equal to 1 over 8 squared. And remember, we don't want this thing with the 1 here like a fraction like this. So we learn to do what? Move this up. Remember, we got to move this up so that we get rid of this fraction. But then remember that exponent changes. So that's going to be 8 to the power of x equals... If this is 8 to the power of positive 2, when you move it up, it's going to be what? 8 to the power of what? This positive 2 becomes now negative 2. And then here's the deal where what? Once we have the same base, which is 8, 8, once these are the same, then I can just work with, I can work and solve what's up here, but pretty much it's telling you the answer, right? X is equal to what? Negative 2. Okay, those two, we've seen these type. Now let's look at the new type now. Oh, actually one more, sorry. One more real quick one, number 3. What about this? Number 3. Log of, let's go with 10,000. What do we do here? I mean, aren't there supposed to be 3 numbers or 2 numbers or something? Well, yeah. Well, remember, it says 10,000, right? Yes, I'm supposed to put equals x because there's supposed to be equals x over here. And remember, when a logarithm doesn't have a base, what's the base? 10. Remember, if it's not written, then it's understood that logarithms are work in base 10. So you have to know that if it doesn't have a little number, a little base written here, it's 10. Okay, we mentioned that before. Now that I have all the parts here that I need, I change this to exponential form. When I change this to exponential form, it's going to read what? 10 to the power of x is equal to what? 10,000. And can you write 10,000 with a base of 10, right? Because from here, it's just about bases and exponents. The answer is yes, you can write 10,000. Well, notice that 10 to the power of 1 has 1 0. Notice 10 to the power of 2 has 2 0. 10 to the power of 3 is going to have 3 zeros. See, the power tells you how many zeros. So what's going to be 10,000? 10,000 is going to be 10 to the power of what? 1, 2, 3, 4, right? So I got 10 to the power of x is equal to what? What's this? 10 to the power of 4. Yeah. If it's 4, you got 4 zeros. And then you just solve for x. Well, x is equal to 4. Okay. All right, now the new ones. Number 4. Here's the ones that kind of look weird. Don't think it's one of the other ones. What if I give you log 8, 2? See, don't assume. I know some of you are like, oh yeah, 2 to the power of 3 is 8. Well, it is, but that's not the answer here. So just stick to the process, stick to the steps, stick to showing your work and doing the steps. I'm going to not guess, not predict, not assume. I'm going to change it to exponential form. And this is now going to say what? This is now going to say 8 to the power of x is equal to 2. Okay, and now we're actually going to get answers that are fractions, and you're not going to see it here. But let's just, again, stop trying to think and predict answers. Just go with what I'm telling you and the way I've been teaching you. At this point, we're trying to get, it's just working with bases and exponents. At this point, you're just trying to get the same base, like we did here. Once we get the same base, then we work up here with the exponents. But your first objective is to get the same base. So if I have a 2 and an 8, can you guys agree that the base is 2 here, and I can write 8 as a power of 2? Yes. Now I know 2 is 2, but it does have a power, right? 2 is 2 to the power of 1. Remember, let's write that. Let's write that now because we're going to need that. And this 8 is 2 to the power of 3. But see, you still have that x right there. 8 is 2 to the power of 3, and this x is up here. It's still there. And we talked about this in the previous assignment. When you get a power to a power, these multiply. So 3 times x will be 2 to the power of 3x is equal to 2 to the power of what? 1. Remember, these multiply, so 3 times x, 3x. 2 has a power, it's 1. And just keep in mind what you're doing here. We're just right now focusing on getting the same base. And this is what we accomplished. We got the same base. That's what's going on here. That's my first concern. I'm getting the same base. Once these bases match, then you turn your attention over here, and then we solve it. And then we solve it here. See? And we did that in the previous two worksheets, right? How do you solve now? This one, it says what? 3x equals 1. Well, the answer is going to be what? X is equal to, divide by 3, 1/3. Okay? Again, this is one of these easy ones, but it's going to build up. All right, let's keep going. Number 5. Number 5, again, if I'm going too fast or something you missed, the good thing is you can what? Rewind it. You can listen again to what I'm saying or what I said. You can watch it again. Okay, number 5. I'm just going to go quick now because I think I've made my point. And what is my point? Don't guess. Don't think, oh, here's a 5 and here's a 25. The answer is 2. No, see, it's not going to be that. Sometimes it'll be the easy one, right? Is it this one or is it this one? Uh-oh. You see? I see a 5 and a 25. I see a 5 and a 25. Watch out, because don't think it's always 2. It's not going to be. So the point is, again, stick to the steps. Don't try to guess or predict. We're doing the same thing. We're going to put equals x. We're going to change it to exponential form. And what is that going to say when you rewrite it in exponential form? Well, that's going to say 25 to the power of x is equal to 5. The answer here is not 2, see? But don't worry about all that. You just worry at this point about getting the same base. This one is 5, which is 5 to the power of 1. I know the base is 5. This one is 5 squared, right? 5 squared is 25, but you remember you still have this x right here. Long story short, that's going to be what? That's going to be 5 to the power of 2x is equal to 5 to the power of 1. See, you got the same base. Once you have the same base, you're done with the bases. You solve up here. Well, again, this one was kind of easy, right? 2x is equal to 1. Solve for x, divide by 2, you get x equals 1/2. All right, let's keep going. Now let's pick it up and make it interesting here. Number 6. What about log 32? What about log 32 4? Okay, well that's going to be log 32 4 equals x, right? We got to put equals x. We need to have all the pieces here, so now we can change this and rewrite it in what? Exponential form. 32 to the power of x is equal to what? 32 to the power of x is equal to 4. Now I'm looking at 32 and I'm looking at 4. 4 to the power of 1 is 4. 4 to the power of 2 is 16. 4 to the power of 3 is 64. You cannot write 32 with a base of 4. But in the other assignment, if this smaller base doesn't work, then you look for a number that works, that can be for both of them. That's going to be, okay, so the common base here is going to be a 2. Since 4 doesn't work, we think of a number lower than that. Well, it's 2. 4 I can write as 2 squared equals, right? I'm trying to get the same base. And 32 is what? 2 to the power of 5. 2 to the power of 5 for 32 times this x, well, that's going to be 2 to the power of 5x. All right, so what did I get now there? Right, getting the same base. I got the same base. 2 to the power of 5x is equal to 2 to the power of 2. See, that's the main thing I'm telling you. I've been saying it. It's all about bases and exponents. Once you got the base the same, then you just got to solve up here. That's going to be 5x is equal to 2. Once these are equal to each other, then you set the expressions up here for these exponents. You set those equal. X is equal to 2 over 5. Okay, 7. Log 1 over 81. What? Oh, no, I wrote that wrong. Sorry. Log 81 1/3. The fraction is here. That's the base. Okay, well, you know what we're going to do. We're going to put equals x. What? Equals x. Then we're going to change it to exponential form. It's going to be 81 to the power of x is equal to 1/3. And what do we do here? Let's not forget. Oh, we're trying to get the same base. Get the same base, same base, same base. So that's going to be 1/3. And 81 can be written with a base of 3, yes. And remember, this is 3 to the power of 1. This is 3 to the power of 1. We want to see a base and an exponent. This is going to be 3 to the power of 4. So that is 3 to the power of 4, and don't forget the x. And then what? Well, we don't want this 1 and 3, 1 over 3, or 1, 3 to the 1. We move this up. It'll be 3 to the 4x equals 3. And that 1 is going to be, it's positive 1. You move it up as a negative 1 exponent. All right, I got the same base. Now we just solve right here, right? Well, 4x is equal to negative 1. That's going to be x is equal to negative 1/4. Okay, last one. 8. Save the best for last. 8. Here we go. Let's go. Log 1/4 32. Woohoo! Log 1/4 32 equals x. Change it to exponential form. Don't think, don't worry. We'll get to it. 1/4 to the power of x is equal to 1/4 to the power of x is equal to 32. Oh, we just saw this. We saw something like this. We cannot write for 32 with a base 4, but remember 2 can be the common base here. So that's going to be 1 over what? 2 squared for 4, right? This 4 becomes 2 squared. This 4 becomes 2 squared. 2 squared is 4. And 32 is what? 2 to the power of 5. Yeah. And then we move this up. This 2 squared moves up. So that'll be 2 to the power of negative 2. And don't forget you got that x still is equal to 2 to the power of 5. All right, so that's going to be what? 2 to the power of negative 2x equals what? 2 to the power of 5. We got the same base. We don't need to look at there anymore. We just solve up here. That's going to be negative 2x equals 5. That's going to be x equals negative 5 over 2. All right, there it is. Good luck.